the 17th century, the world stood on the edge of transformation. For thousands of years, humanity had looked at the stars in wonder, had watched objects fall to the ground, had observed the motion of the planets. But no one truly understood the hidden laws behind these movements. Europe was awakening. Old traditions were being questioned. Ancient authorities were no longer accepted without proof. The English philosopher Francis Bacon called for experimentation instead of blind belief. The French thinker René Descartes demanded reason and logic, and astronomers like Galileo Galilei had already begun shaking the foundations of old science. Using the telescope, Galileo observed moons orbiting Jupiter, proof that not everything revolved around Earth. Meanwhile, Johannes Kepler mathematically described how planets move around the sun. Science was progressing, but it was incomplete. There were discoveries, but no unifying system. Facts existed, but no master key to connect them all. Then, in 1643, in England, a premature and fragile child was born. Few could have imagined that this quiet boy would one day unlock the mechanics of the universe. His name was Isaac Newton. Newton was not known for charm or social grace. He was introverted, intense, deeply focused. As a young man at Cambridge University, he showed extraordinary talent. Then came the year 1665. A devastating plague forced the university to close. Newton returned home. Isolation followed. But in that isolation, something extraordinary happened. During those quiet years, Newton developed the foundations of calculus, began thinking deeply about gravity, and experimented with light. It was one of the most productive periods of intellectual discovery in human history. Let us begin with light. For centuries, people believed white light was pure. Newton proved otherwise. Through careful prism experiments, he demonstrated that white light is actually a mixture of all the colors of the rainbow: red, orange, yellow, green, blue, indigo, violet. He did not guess this. He proved it. He even built the first practical reflecting telescope in 1668, a design still used in modern observatories. But optics was only a small part of his genius. Newton's greatest contribution was in understanding motion. Before Newton, Galileo had described how objects behave when no forces act upon them. But what happens when forces do act? Newton answered that question forever. His first law of motion explained inertia, that an object remains at rest or in motion unless acted upon by a force. With that single formula, Newton gave the world a way to calculate motion. And then came the third law. For every action, there is an equal and opposite reaction. Simple, elegant, universal. But Newton's most famous insight came from a deeper question. Why do apples fall? Why does the moon not drift away into space? Newton realized that the same force pulling an apple to Earth was also holding the moon in orbit. Gravity. Not just Earth's gravity. Universal gravitation. Every object in the universe attracts every other object. With this one idea, Newton connected the heavens and the Earth under a single law. For the first time in history, the movement of planets could be predicted with mathematical precision. In 1687, Newton published his masterpiece, Philosophia Naturalis Principia Mathematica, often simply called the Principia. In it, he laid out the laws of motion and universal gravitation. It was not merely a book, it was a revolution. The Principia transformed science from scattered observations into a unified mathematical system. From that moment on, the universe was no longer chaos. It was order, predictable, calculable. Engineers could now design machines with precision. Astronomers could predict eclipses. Artillery officers could calculate projectile paths. Centuries later, Newton's laws would guide rockets into space. Think about that. The same equations written in the 1600s helped send humans to the moon. Few individuals in history have had such sweeping influence. When Newton died in 1727, He was buried in Westminster Abbey, an honor rarely given. He was the first scientist to receive such recognition. This is not just the story of a scientist. This is the story of the man who gave us the laws of the universe. Story of Newton. Story